Hello everybody. Now we will discuss the differentiabilities there. But before that, if we talk about the differentiation, so if you are saying simply, you are saying what will be the differentiation of the sin x, differentiation of the sin x. तो differentiation नहीं होता है, that is the derivative of the sin x होता है, ना कि differentiation. Differentiation means that is the process by which we are getting the derivative of this function. That is known as a differentiation. So always you are supposed to say the derivative of the sin x, derivative of the cos x is there, and that derivative is generally denoted by, like any one of the function is given, fx is your function, a function that can be denoted by f dash x, or sometimes we are saying d over dx, fx. Like these are the symbols which we use for the derivative is there only. So derivative of any of the function is f dash x is equal to limit s tends to 0, where f x plus h minus fx over h. This is the by which we can find the derivative of the function is there. Or you can see the first principle method. See, now differentiability, if we talk, the function is said to be differentiable on an open interval. Means any function will be the differentiable in an open interval if it is differentiable at every point of the interval. If this is differentiable at every point of this open interval, means this a and b is not included. For instance, C is going to belong to this AB, then L f dash C must be equal to right hand of this f dash C is there only. And if it is a closed interval is there AB, then f will be the differentiable at every point of the interval of this closed interval if right hand derivative and the left hand derivative are equal, then it will be differentiable is there. So right hand derivative we will write limit s tends to 0 f c plus h minus f c over h. Sometimes we are putting the pluses here. And for this one, left hand s tends to 0 minus, you can say f c minus h minus fs, f c over, here is the minus is there, where h belongs to x. So any function will be differentiable in this closed interval if the right hand derivative is equal to the left hand derivative, then that will be the differentiable at the closed interval is there only. And have a look. Now the differentiability and geometrical meaning of a derivative at a point. What is the geometrical meaning of derivative of a point is there? If the function y equal to fx is a function is said to be differentiable at this point x equal to a, then unit tangent can be drawn. Means suppose the function you are taking y equal to x square, and if you are going to draw the graph, you will get this graph is there. So at x equal to 1, you are going to put y equal to 1. So at this point 1 1, you will get the unit tangent is here only. So at x equal to 1, this function will be the differentiable is there only. So unit tangent can be drawn to the curve, and you know the function y equal to fx at x equal to a. From the left and the right exist, then we same straight line is there. But in case if left hand derivative and right hand derivative are finite but unequal, they are finite but they are not equal, means the left hand derivative and the right hand derivative, you can say LHD is, they are finite but they are not equal, right hand derivative, then geometrically implies a sharp corner at that particular point. इसका मतलब ये हुआ कि उस पर्टिकुलर पॉइंट पर देयर बी द शार्प कॉर्नर. लाइक हियर इज द, you are taking the function fx equal to absolute x. So if you will draw the graph of this one at x equal to 0, you are getting the sharp corner is here only, sharp corner. At x equal to 0, this function is not differentiable. So if the sharp corner found in any of the curve, that at that point the function will not be the differentiable. So here is the sharp corner is seen at x equal to a in the this one, so this function will not be the differentiable. Have a look. Okay, now the question is, so that fx equal to x square is differentiable at x equal to 1, and you are supposed to find the value of f dash 1 is there only. So it is differentiable at x equal to 1, it means the right hand derivative and left hand derivative must be equal. At this point is there only. So right hand derivative at x equal to 1, so that will be limit x tends to 1 plus fx minus f1 over x minus f1, and this is can be written as limit s tends to 0 if 1 plus h minus f1 over 1 plus h minus 1 here. So finally here you will get limit s tends to 0 if 1 plus h minus f1 over h. This is cancelled out. So now here is your function is what is fx equal to this one. So this is limit s tends to 0. This is 1 plus h whole square minus 1 square over h. You will solve this one only. So limit s tends to 0. This is 1 plus h square plus 2h. A plus b whole square you can apply. Minus 1 over h is here. This is cancelled out. So you will get this is limit s tends to 0 h square plus 2h over h. You can take out the h is common from here in numerator. Otherwise you will get the independent form is there. So h is take out. So you will get h plus 2 over h. Cancel and just put h equal to 0 is here. 0 plus 2. So this is 2. So the right hand derivative at 1 is equal to 2. Similarly, left hand derivative at x equal to 1. So this will be equal to limit x tends to 1 minus fx minus f1 over x minus 1. And this is equal to limit s tends to 0 if 1 minus h minus f1 over 1 minus h minus 1. This is. So finally here you will get limit s tends to 0 if 1 minus h minus f1 over, you can cancel this is, you are getting the minus s, then directly you can put this one is also. Up now this is your limit s tends to 0 and fx is equal to this x square, so this will be 1 minus h whole square minus 1 whole square over minus h. You will solve this one, you will get limit s tends to 0. This is your 1 plus h square minus 2h and minus 1 over minus h is here. So this 1 and 1 you can cancel out. So look at here now. I am going to rub here only. This is the portion. So look at here now. So here you will get limit h tends to 0. This is h square minus 2h over minus h. You can take out the h is common. You can take out the h is common from here only. So you will take the h is common is here. You will get h minus 2 over minus h. You can cancel. So this is equal to limit h tends to 0 h minus 2 over minus 1. You will put 0 is here. 0 minus 2 over minus 1. So this is 2. So it means finally what you are getting? We are getting the right hand limit derivative. Look at here. Right hand derivative is also the 2. So here you are getting right hand derivative is equal to left hand derivative at x equal to 1. You are getting 2 is there at 2. This is there. Means right hand derivative this was you are getting. It means what will be the value of the f dash x will be equal to the 2 is there. So fx is differentiable at x equal to 1. It will be differentiated at x equal to 1 and that will be equal to the value itself. Means f dash 1 will be equal to the 2 is here only. Have a look. Yes. One more question we are taking. Then we are supposed to show that fx is equal to greatest integer function. This is your greatest integer function. Is not differentiable at x equal to 1. This is your greatest integer function is there only. So you are supposed to check again right hand limit, right hand derivative and the left hand derivative must be equal. So your function is fx equal to this one. So right hand derivative of this one, limit x tends to 1 plus fx minus f1 over x minus 1, that is equal to limit s tends to 0 f1 plus h minus f1 over 1 plus h minus 1. 1 will cancel out here, we will get h. This is limit s tends to 0 1 plus h, because your function is fx equal to this one. So f1 plus h is 1 plus h is here, minus 1 over this one. See, if 1 plus h here, that will be equal to the 1, because according to the condition, you know, here is 0, then here is 1, and 2 minus 1 is here. So 1 plus h, it means you are somewhere here anywhere, but you will come to here only. So the value of this 1 plus h will be the 1 is here, and because exactly at the 1 is there, so then greatest value of this one is will be the 1. So here is the 1 minus 1 over h. 0 minus 1 means 0 over h, s tends to 0. So 0 over h means that is 0 is there. So limit s tends to 0. So you are getting here is 0. It means the right hand derivative is equal to 0. Now we will for the left hand derivative. So x tends to 1 minus fx minus f1 over x minus 1. Same, s tends to 0. f1 minus h minus f1 over 1 minus h minus 1. You cancel. Here you will get minus h here. Now 1 minus h minus 1. 1 minus h is, means here only 1 minus h. We are going to subtract h from 1. It means you are somewhere. यहाँ कहीं पर है. So you will come to here for the greatest value, that is 0. So this is 0 minus 1 over minus h. So this is minus 1 over minus h, minus cancel out. You will get limit s tends to 0 1 over h. And as you are going to put the value of h is here 1 over h, and h is 0. If it is h is 0, it means it will tend to the infinity if s tends to 0 is there only. So that is infinity. So right hand derivative you are getting at 0, left hand derivative you are getting infinity, and it means they are not equal. Right hand derivative and is not equal to the left hand derivative. It means you can say this function fx is equal to greatest integer function x is not differentiable at x is equal to 1. So it is not differentiable. Have a look.